Hey students, this video is just to clarify a few questions that you might have on the sunny side up activity. In class together, I had you first predict what you felt the sizes of these planets would be compared to a sun that would be 15 centimeters in diameter. And then I had you practice using your compass drawing these size circles. So first we have our 15 centimeter sun. And this is especially important if maybe you forgot your sketch sheet at home, or if you're a distance learner and I didn't have a compass for you. I'm hoping maybe you tried to draw some nice circles, but if you didn't, you could use my sheet here to help you answer the questions that are on the back side of the front page. Okay, starting here with the post lab questions. So what I first did, these are not the actual sizes. These are just some odd predictions that I made up. And I'm hoping that, or not hoping, but thinking that we are probably all along the same lines of maybe we probably drew the planets too big compared to the sun. Notice that our inner rocky planets like Mercury, Venus, Earth, Mars are all relatively the same size. That's not the case. And Jupiter, Neptune, Saturn, Uranus are all pretty large when we kind of compare them to the sun. So actually, this is how they should look compared to our 15 centimeter diameter sun. All those inner planets are very small. Here are our outer planets, not quite as large as the ones here. So on the second page of the sunny side up activity, we're wondering what can I fill in here? We did this part together. We created the model and computed the scale factor. If you recall, the scale factor was the number that we divided to determine how much 1 centimeter on our scale map would be. So our scale factor is actually this number right here, 92,793. You can write that in if you want to. So 1 centimeter on each of our drawings represents 92,793 kilometers. So with number 1, it asks you make 3 observations or comparisons to the actual about the model you created. That's kind of a mouthful. So essentially what that means is please compare your actual diameters, so the true amounts, compare that to your drawing that you had when you predicted the sizes. How are they different? And number 2, use a calculator to add up the total diameter of all of the planets and Pluto. All right, then you write in that total diameter. The numbers you're adding here, add these numbers right here. Add these numbers all together. Okay, except not the sun. Okay, you're going to be comparing all these amounts to the sun. Okay, so you add Mercury through Pluto. Write that number here, and then compare that number to what the sun's diameter is. And then what do you notice? Record that here. Number 3, this is after completing this activity, you should be able to explain why our solar system is heliocentric. Why do all the planets revolve around the sun and not a different body? So you kind of got to make your own prediction there after you find out what heliocentric means. It's just an easy search. Search up heliocentric online. This word is easily broken up in 2 parts. Helio meaning sun, centric meaning, I think you can think about what the word centric means. Okay, so sun-centric, what does that mean? And then you're good to go. You're just making observations based off your models. Thanks.